Hey guys, today we're talking about rules of exponents. When I have 3 squared and I multiply it by 3 to the 4th power, it equals 3 to the 6th power. Why, you ask? Well, because if we break it apart into factors, 3 times 3, or 3 times itself twice, is 2 3s. 3 to the 4th power is 3 times itself 4 times. So when we look at these, they're all being multiplied. So how many 3's do I have being multiplied? A total of 6. 6 total factors. So the rule, and you might want to write this down, is that to multiply powers with the same base, you can just add their exponents. It's kind of a little trick, but the reasoning behind that is because, in fact, you're multiplying the number that you have here of those 3's by the number that you have here of those 3's. So there's a total of 6 here. Down here, there would be 4 2's times 3 2's, which would give you 7 2's. So that's why this step allows us to just quickly add and assess how many we have. The algebra behind it is if we have the same base, let's call that A, and we have an exponent m and an exponent n, we're going to add m plus n and keep their same base. Let's put this into practice. If I have 2 to the 7th power times 2 to the negative 4th, really I have 2 to the 7th power plus the negative 4. So how many do I have? I have 2 to the 3rd power. Here I have a base of 5, and it's a negative 2 plus 3. So if I have a negative 2 plus 3, I really have 5 to the 1st power. If I have a to the 2nd power, I'm adding a to the negative 5th, so I really have a to the 3rd power. If I have a coefficient in front of the variable, that's what we call the 2 and the 4, they're coefficients. We first multiply those just like we would in general, and then we worry about the a's. So now it would be 8 a to the 3rd plus the negative 2, which would give us 8 a to the 1st power, which we know anything to the 1st power is itself. So just like up here with the 5, it could just be 5, and he could just be a. What if we have a fraction? Well, same thing. 1 to the 2nd power, or excuse me, 1/2 to the 2nd power plus your 7 gives you 1/2 to the 9th power. If you were asked to evaluate this, then you would think, okay, what's 1 to the 9th power? Okay, it's itself. What's 2 to the 9th power? It would be 512. So, but really, for our purposes, we could leave it like this if we wanted to. Sometimes they're going to ask you, though, to evaluate, and this would be left exponentially. This is an evaluation. Go ahead and try these, and I'll be back in just a second to show you the answer. Make sure you evaluate this one for me. Okay, I'll be back in just a second. Ready, set, go. Okay, here are my answers. Okay, so for this first one, I'd add my 3 and my 4, and I'd get 2 to the 7th power. Here I'd add the 2 with the 3 and get 5 to the 5th. I'd get a to the 6th by adding 2 and 4. Down here, I'd have to multiply these two first to get 6, then take 5 plus a negative 4 and get b to the 1st power, which is just b. Down here, I'd add my 3 and my 5, and I'd get 8, so it's 1/4 to the 8th power. Now, I know this is 1, and 4 to the power of 8 gives me a really big number. Ready for it? 65,536. Okay, that's evaluated. This is left in exponential form. What about division? If we look at this one, 5 to the 7th power divided by 5 to the 4th power is 5 to the 3rd. Here's why. Because if we have 7 factors on top and 4 on the bottom, these could cancel out, just like if we were working with fractions. So what we're left with are 3 factors of 5, which is 5 times 5 times 5, or 5 cubed. So the trick is to subtract. take your 3/7 and subtract the 3. So 3 to the 7th power minus 3 is 3 to the 4th power. For algebra, as long as you have the same base, let's call it a, and you have the exponent m in the numerator, you would take the m minus the exponent in the denominator, which we're calling n, and we would subtract. A cannot be 0 though. Making sure that a is never 0 is key, because that would give you that divide by 0 error, which is no solution. So that's why you have to be careful of that little piece of information. Okay, so let's look at these two examples. Y to the 5th power divided by y to the 2nd power would be like subtracting the two exponents and leaving us with y to the 3rd power. Here, it would be like taking 3 minus 2, which would just leave us with x. Go ahead and try these two for me. These ones have negatives, so be careful. Remember, not nuts. I'll be back in just a second to show you the answers. Okay, so let's look at these two. Y to the 5th is like taking y to the 5th minus a -2, which is a not, which gives you y to the 7th. Here, y to the 4th divided by y to the 6th, if we took 4 minus 6, we're going to get y to the -2nd power. That always stays in the bottom. If you have a negative exponent, it goes on the bottom. So we're going to leave him there because there's 2 still in the denominator. If I have x to the -3rd minus 2, it's like having x to the -5th. So again, he goes on the bottom because a -5th power can be shown like so. So what we really have is 1 over y to the 2nd, x to the 5th. Okay, try these for me, and I'll be back in just a second to show you the answers. This is a review of all of them. Go ahead and pause the video, make sure you take your time, and then when you're ready, get out your red pen and we'll check it. Okay, I'm going to show you what we would do first. For the first one, you should have gotten, whoa, I didn't mean to move that far. You should have taken 5 to the 2nd times 5, which is kind of like 5 to the 1st, and you would have gotten 5 to the 3rd, which gives you, if you evaluate, this left as an exponent, this is how you evaluate 125. You can also check your work just to make sure that you're doing it right. For the second one, we would get c to the 8th power because you're adding your 3 and your 5. For the third one, we would have to first multiply our -3 times our 4 and get -12. Then we would add our 2 plus our 5 and get x to the 7th power. Oops, it's not letting me do that. There we go. Oh. For this one, we would get 4 to the 8th power, and we would have to subtract the 2 from the 8 because it's division. So we get 4 to the 6th power, which is really 4,096. Okay, what about the fifth one? Again, we would subtract and we would get n to the 5th power because 9 minus 4 is 5. And finally, for the last one, this is a big one, guys. We would first have to subtract here and get 2 to the 3rd power, subtract here and get 3 to the 1st power, subtract here and get 5 to the 1st power. So we have 2 to the 3rd power, which is really 8. Then we have 3 to the 1st power, which is really 3, and 5 to the 1st power, which is really 5. So 8 times 3 times 5 gives us 120. And that, my friends, is all I've got for you today. I will see you next time.